Vice President and Principal. Please help me welcome Sueanne Pfifferling and her team this morning.
Thank you all for being here, staying after the break, coming back. We're going to try to discuss designating feedstocks and intermediates today. As Jeff said in his explanation, it is a proposed rule pending before USDA that they hope to finalize in September that would allow for the designation of feedstocks and intermediates under the mandatory program. Currently, and this gets to a question I think that Charlie asked before, you can get a label for intermediates and feedstocks, but Congress decided in the 2008 Farm Bill to create a process where USDA could actually designate intermediate and feedstock with the idea that end products made from those intermediates or feedstocks would be eligible almost automatically for designation on the preferred purchasing list. And what we're going to discuss today is a way of going from those feedstocks and intermediates to designated products for mandatory purchasing. And let me begin by introducing our panel. First we have Justine Lee. Justine, I should say doctor, I'm surrounded by all these chemists, chemical engineers. Justine is the Director of Strategic Marketing for ADM Renewable Chemicals. She is currently leading a cross-business unit marketing teams to bring the entire breadth of ADM's biochemical portfolio, including its products and technology, to customer base. Prior to joining ADM, we worked at BASF, and Justine holds both a business degree and MBA from MIT Sloan School in Management and a PhD in chemistry, biochemistry from Georgia Tech. The order here is because Charlie also is from Georgia Tech, has his education from Georgia Tech. Charlie Morris is the President and COO of the Pine Chemicals Association. He is also a chemical engineer with a degree from Georgia Tech. Charlie worked for, I never realized there was an Army Chemical Corps, but Charlie was an officer of the Army Chemical Corps and has done a lot of work on oils, which I will have to explain, pine chemistry, with a number of companies, including working for Georgia Pacific in their specialty chemicals group. Next, we have Dr. Ramani Narayan, who is the University Distinguished Professor at Michigan State in the Department of Chemical Engineering and Materials Science. Dr. Narayan, as he introduced himself before, is an academic, has 28 patents, however, and has done research that encompasses design and engineering of sustainable bio-based products, biodegradable plastics and polymers, biofiber reinforced composites, and when we were talking about the test that's used to determine bio-based content, the ASTM test, Dr. Narayan was chair of the committee that developed that test to distinguish a new carbon from old carbon. And then finally we have Dr. Reena Singh, who is the Senior Director of Policy and Science and Renewable Chemicals for the Biotechnology Industry Organization, or BIO as it's called. Reena served, before coming to BIO, worked with Ashland Incorporated, and before that, she started her career at Dow Chemical, and has a doctorate, or bachelor's degree in chemistry, and a doctorate in natural products from McGill, Northbrook Hill. So we have a lot of technical, chemical brain power up here, where we hope to go through this, the question feedstocks and the challenges that face USDA, but also, hopefully, the benefits of the pull-through of this new market. So I'd like to start by asking each of you, if you will, to tell us how you see the designation of feedstocks and intermediates helping to expand and drive the end use for bio-based products. And if you can give a few examples from your industries or experience about how you would go from a feedstock to an intermediate to an end use product that USDA could designate that's actually being bought by the government purchasing agencies. Just
Better now? Good. So first I want to take a step back and think about the trend. As the industry evolved, we're still a very young industry. As the industry evolved, a lot of these suppliers on the chemical side, bio-based chemical side, are trying to organize their product that's more market-facing to address the needs of the customer in specific market segments. As Sueanne mentioned earlier, ADM is doing the same thing right now. I'm leading that effort. So from the trend perspective, by having a designation of chemical intermediates and complex products according to different market segments and value chains is aligned with that trend. So it's a good thing. So I want to talk about a few examples. Being a chemist myself, there are two different types of bio-based product. In my view, one is a drop-in replacement, which means that the chemical structure of your bio-based product is identical to the petrol-based chemical. An example from ADM will be propylene glycol. So we have bio-based, 100% bio-based propylene glycol, which is chemically identical to the petrol-based propylene glycol. And it has certain applications. And among other applications, I'm going to name two. One is heat transfer fluid, and the other one is used as airline de-icing fluid. For those of you who have been stuck in the airport and all of a sudden you need de-icing, you smell this maple flavor, like maple syrup flavor, and that's propylene glycol. And a lot of the airport use our PG for that purpose. So that is a chemical identical product compared with the petrochemical counterpart. By having a designation like this, it will bring to the end user the awareness there is a bio-based product available that's called PG, propylene glycol, that can be used for these applications. So I think that's one thing, to bring awareness of the end customers, so create that pull-through. Of course, everything depends on how it's going to be implemented. So I'm really hoping that this is going to be implemented well and works for the industry. The second type of bio-based chemical, they are not drop-in replacement, meaning that it has certain features or even better features compared with the petrol-based product, whether it's a plasticized or whatnot. But chemically, it's a new entity compared with the old product. And I can give you a couple examples there as well. For example, we have a product which is soybean-based, and it's called CA118. It's a low VOC coalescent that is manufactured for water-based industrial and architecture coating, and also pigments, and as well as adhesive and caulks. So by having a designation like this, it will again bring to the awareness of the end customers, say we have an intermediate that's bio-based that can help you to meet your VOC regulation for those producers. So that certainly helps. And the next example I'm going to talk about is going to be a little bit on the challenge side. So we also have a product that's more on the complex product side. So it's a corn and wheat-based starch that can be used to remove paint from airplanes. And I mean, we have product that's already meeting the specification, military specification of these glass medias. And the alternative, the petrol size of the incumbent, that is an acrylic, a plastic-based product. So our product is scientifically proved to be just as good and plus competitive, and has already been used by military base. But however, most of the military base, they're not aware of this product. So for us to go sell this bio-based product to promote agriculture business in the United States, we literally have to bring a lot of donuts And for those days, I don't wear high heels. So you have to go door by door and knock at the door and tell them this product exists. And I think that having a destination like this, people will be aware and say, all right, so now we got this acrylic-based plastic that you can use as a glass media. In the meantime, you also have this bio-based product that can be used as a media. I think that will help. But again, at the end of the day, it's not about what, it's about how. And we want to make sure that we work together with the government to make sure the implementation will go favorably for the industry.
Thank you again. My name is Charlie Morris. I'm the president of the Pine Chemicals Association. And for those of you who don't know what pine chemicals are, you know what a pine tree is, but when they process a pine tree in paper making, you extract all these chemicals, and from those come two primary products. One is rosin, the other is fatty acid. Fatty acid actually is quite similar to soybean fatty acid, and the rosin is similar to rosin you might get out of a pine tree if you tap the tree and recover that sap and then process it into rosin. These products turn into a multi-billion-dollar industry in the United States, and you probably see or touch them every day, even though you don't know it. For example, these products go into paints and coatings, they go into adhesives, they go into inks. Probably some of the inks on these papers here are made out of toluol-based rosins. They go into road market adhesives, they go into synthetic rubber manufacturers, so the tires that you're driving on trucks or cars are made based on a pine tree chemical. So then the pitch, which is another piece that comes out, actually goes into making asphalts, goes into making a food additive that reduces the cholesterol in your body and kind of tricks the body to believe it's a natural cholesterol, therefore the cholesterol doesn't accumulate in your body. So there are a lot of applications and uses of these products, but they are intermediate chemicals. And we just talked about they're not drop-ins, they're alternatives to fossil fuels. So to go to the question, why would what's the market driver for these products? A lot of it is performance. They're readily available, they perform very well, and in fact, in many cases, outperform things. Most cases, they outperform the petrochemical alternative, but there are times when the petrochemical may be equal and there's a choice between the chemists formulating, and what we would like to see is the chemists be aware and have a little bit more pull with the consideration that these are bio-based products that come from the pine tree. And we think that with this whole bio-preferred labeling process that the USDA is now putting forth, it will help the marketing of the products. Up to now, our products were excluded because our industry has really been doing what I think they're trying to do now. We've been doing it for a lot of years. So now with the new recently passed regulations and the new bill, they're going to accept mature products. We're a very innovative industry. We've made a lot of changes over the years in our products and our processing, but we've been around for a long time. So now, hopefully, we will be able to also include that bio-preferred label, which I think will be very helpful.
So as you know, I'm a professor, so I'm supposed to teach, so it's a teaching book. So let me take that question that Sueanne posed and subdivide it into...
Cameron, can you turn it off?
Got it, sorry. My fault, I didn't know. So the goal is to subdivide it into sub-questions so it's easily digestible for you, right? So the first part, I want to define what is the intermediates and feedstocks, because we can talk about where it is. And I define it, at least for the purposes of our discussion, as something which is not your final product which you give to the customer. You remember the famous commercial, you don't see our name in it, but it's the ingredient which is present in the product. So these intermediates and feedstocks are considered to be what you can use. The value proposition, of course, for the USDA to basically provide a designation and make it available for others so that they can use it in the products they are trying to use to the end customer, right? So I think it's a very important step in defining these intermediates and feedstocks, and therefore encourage the industry to utilize these feedstocks, intermediates into products, thereby expanding the reach of bio-based products. I think that is, at least my opinion, my thinking, the rationale for designating these. The second part then is, what are these examples? And let me take some of them. Many of you may be familiar with polylactic acid, and hopefully I don't leave anybody out of this name nomenclature. But PLA is available, but PLA can be made into plasticware, it can be made into film, it can go into foams, polyurethanes. There's a whole host of products it can go into. By designating it as a USDA intermediate, it encourages other converters to see how and where and why they can use PLA in their products, thereby piggybacking on that biopreferred designation, and how it is done, how it is executed, what percent bio-based content, that needs to be defined, but it certainly opens it up. Another example is, you're all familiar, if you must be familiar with the baked Coca-Cola plant bottle. But what you don't or may not be aware is that plant bottle essentially has a component which is it's an ethylene glycol, it's a component which is bio-based. So if instead of saying plant bottle is the designated product, it means you're just identifying one product, you designate bio-based ethylene glycol as an intermediate, then